So, welcome. So rapid mobile app delivery, you can find me online at Thomakos and various related sites if you're interested in reaching out to me again. So I work at Strava. We are a social network for athletes. We let you share, compare, analyze, kind of do cool stuff with your run, ride, swim data. London is actually one of our most active areas, and we have a satellite office here as well, primarily marketing. And we're headquartered in San Francisco, which is where I'm joining you from today. If I yawn during the presentation, it's because I still have jet lag, not because I find the content boring. So I want to tell you a little bit about how we automated our mobile release pipeline and subsequently also cut that release time in half. But first I want to give you a little bit of background on the app itself so you can get a sense of what we were dealing with. So we have two main native applications, an iOS and an Android app. And between the two main repos of these apps, we merge on the order of about 100 commits per week. Each app is translated and available in about 15 different languages. And there's a lot of functionality in the app that's based around GPS data or location data. So I can tell Strava to record my run at intervals so that when I get home, combined with other information like my accelerometer or third-party biometric trackers, I can get a lot of information like pace, heart rate, distance, elevation, moving time, like a whole slew of data. And there's also some live functionality built into the app around timing and, for instance, some safety functionality. So if I go for a run, I want my wife to know where I am. I can send her a little beacon so she can keep track of where I am, and she'll get notified if I stop for too long. So there's kind of interaction that's native to the app, but also contacting the server while you're actually running or riding. Once you're actually done exercising, you can view your activities, you can upload pictures, you can dig into your data, you can view your friends' data, you can give them kudos and say good job, and you can complete challenges or goals and get notified about those as well. So there's a lot of post-activity functionality built into the app as well. So in continuous delivery, we're often thinking about web apps primarily. And at Strava, we do have a web app, and we do continuous integration and continuous delivery and blah, blah, blah. But I wanted to set the scene a little bit for the mobile apps because we didn't just convert a simple read-only application to continuous delivery. We actually, I wanted to show that it's possible to move towards continuous delivery, even with an app that depends highly on native functionality and native libraries. But there's actually more, because mobile apps have additional complexities compared with web applications. So how many of you have heard this motto before, move fast and break things? This is like the Silicon Valley motto. And to be honest, for the web, it's not such a crazy idea. You can kind of roll a new version of your website, a user clicks refresh or navigates to the next page, and they're sort of transparently running the next newest brand new version of your code. On mobile, it's kind of a completely different world. So there are network and compute constraints that we don't have for the web. We don't install websites, but we install mobile applications, which means that our users have to spend some time clicking that install button, waiting for the download to happen, actually opening up that app. And when they want a new version of it, or if something goes wrong, they can't just click a refresh button. Even if they do have that auto-updating feature on, releases are kind of further delayed in other ways. So with Apple, you actually have to get your apps approved before they can be published on the App Store. Android only allows a certain number of releases per day or per week. So I actually had a friend that was seeing a minor bug in a version of the app, of the Strava app, and we checked her version, and this was back when we were releasing every other week, and she was 12 versions behind our most recent release, and the app was still generally working, but that means that she hadn't updated the app in over 6 months. So you can imagine the web equivalent would be you download a web form, you fill it out, and you just let it sit on your desktop for 6 months, and then you try to submit it. Like, the likelihood that that is going to succeed, at least with any kind of modern security practice, is 0. So we also don't rate our websites. I suppose there are websites to do this, but websites aren't delivered in an app store. They aren't packaged up. But Google and Apple rate our apps, and we, even though our websites show up in Google ad rankings and things like that, it's a kind of a completely different marketplace and a completely different interaction. Having a single bad rating, especially early on, can really hurt the prospects of your business or your application. There's also something that's a little more specific to Strava. So I'm a trail runner, and this is my dog, Barney. He's about 9, but he still comes along on all my runs. And because we're often out on the trails, we don't have good GPS connectivity or cell connectivity. And that means that if I upgrade my app and then head out on the trail, I want to know the app is going to work, that it's going to at least reliably retain all the data from that run so that I don't lose it when I get back home, and that hopefully it will still keep pinging my wife so that she knows where I am. So we can't just move fast and break things because there's a little bit more at stake in this experience than there is on the web. So what we really want to do is move fast and not break anything. So we need to kind of reframe continuous delivery for mobile because breaking things has higher consequences. So we've established the stakes. Why even try continuous delivery for mobile in the first place? It seems like a lot of work, right? A lot of risk for sure. So at least for us, there were a few concrete reasons to do so. The first was that we wanted those classic continuous delivery benefits. We wanted to get the features in front of our users sooner so that we could get feedback quickly, so that we could iterate on those ideas and we could deliver value rapidly. We wanted to be able to deliver A/B tests and iterate on those results quickly. If you can imagine, if we were delivering the new mobile app once a quarter, that meant that we'd have to wait a whole quarter before we could release some new version of the app that we actually had proven data would make the user experience better. So going fast has benefits for feature and code turnaround. That's simple. We want that for the web and we want that for mobile. There's also a greater level of stability afforded to us by continuous delivery. Releasing often means that your change sets are smaller. You have less to test. There's less that can go wrong. And because we're continually exercising that release pipeline, we have greater confidence in it. We know that if it breaks, we're going to catch that bug quickly and fix it. And with more frequent releases, we're less likely to cram right at the end to try to get features in. So our app is a little bit more stable, a little bit more reliable, a little less buggy. So we want to do continuous delivery for all those great benefits, even though there are risks. But the existing tool sets and examples in the industry are relatively sparse, so we have to build some things from scratch. So I'm going to walk you through the evolution of our delivery pipeline for our mobile apps, and we'll cover some of the challenges that we faced and the tools that we built to make it possible. So in the beginning, our process was relatively ad hoc. We had maybe a handful of engineers, mobile engineers. We only supported English languages. We just kind of built and released the app because we had some new cool feature that we wanted users to see. But as we added more engineers, more features, more languages, we began to develop a process around mobile releases. So at Strava, this release management process is known as train conducting. And the engineer responsible for a mobile app release is called the train conductor. And she's responsible for getting that 2-week release from cut to production. And at this point, we had grown our mobile engineering organization to 25 engineers. Most of these engineers were also taking a turn in that train conductor rotation. And the reason for this is that we found that larger rotations favor good documentation and shared responsibility. It protects our organization when someone leaves for vacation, chooses to move on to another company. We kind of have that shared knowledge base that we can all fall back on. So you can kind of think of this as like pair programming for your delivery pipeline. Each train conductor spent about 2 weeks reading and referencing, sort of like living in this large single playbook that had all the steps that she needed to follow to get the train all the way to production. The playbook was huge. And when your conducting shift was up, it was someone else's turn to take on that job. But the process was tedious. There were a lot of communication points. So you had to communicate with external QA testers, with translators, with product managers, with developers. And over time, for most developers involved at least, it felt kind of like black magic train conducting with lots of switches and train crossings that you had to watch out for. And, continuing this analogy, there were a lot of manual steps. So this was like very old-timey train conducting, lots of manual labor, shoveling coal into an engine. For example, a beta release involved actually like building a binary on your machine, uploading that binary to the Google Play Store or the iOS Store, sending notes for our beta testers so they knew what they needed to test, and then actually sending a Slack message out to everyone in the company to let them know that a new beta had been built. So kind of a lot of steps and very manual. So in early 2017, I'd been hearing a lot of complaints about this process, how manual it was, how long it was taking, how error-prone it had become. So I sent out a survey to gauge how much time we were actually spending in this process. And it turns out we were spending approximately 20 developer hours per week just managing the release process. And unsurprisingly, the survey demonstrated that train conducting was complex. It was easy to forget steps. The process actually caused people stress. And it took a long time before an employee could ever feel comfortable running a train conductor rotation for the first time, like on the order of months. So the worst part of this was that the process actually didn't scale. So if we actually wanted to release every week instead of every other week, we'd actually have to compact all that work into half the time. And some of our processes likely would not have been able to get done that quickly. So one of the massive benefits of continuous delivery is that we were missing out on is that continuous delivery allows you to speed up or slow down your processes with a lot less friction because a machine is managing most of it. So you can actually scale that process. So we deemed it a worthy task, and we decided we were going to try to automate everything. So I'm going to tell you a little bit about strategy first. How do you actually go about taking that manual process and automating it? So the first phase was to map out all of our manual actions and try to map them directly to some sort of like scheduled or triggered event that a bot could manage. So if you don't already have a release management playbook yet, then I would highly recommend doing that. Having that ad hoc process documented basically means it becomes a little less ad hoc because you get to verbalize all those random assumptions that you may not have ever shared before. And it enables you to have sort of an initial design doc or template for, at the very least, the considerations that you need to make as you're building an automated solution. And it allows you to challenge all of those assumptions as well and determine if all of them actually provide value or if some of them you can actually just toss. So the next step is to choose your bot. And the specific technology you choose is not that important, but you want three main things. You kind of want this to act. You kind of want your bot to act as a central coordinator. So you want it to be able to react to source control changes, to scheduled events, and to other builds in your CI system. So you could do this with micro apps, Lambda functions, a lot of the third-party vendors that are outside in the hall today. It's totally up to you. At Strava, we decided to expand our in-house CI system, which we call Butler. A Butler is a distributed CI. It runs in Amazon Web Services, and it uses Docker containers for isolation and repeatability. So if you have a collection of third-party systems that you already use, you primarily want to make sure that you have API access to those systems so that it's easy to check in on builds and like trigger builds and schedule events. So we decided that each step of our build process would be written in a YAML format. This is what the CI already did. The YAML files are stored in our Git repositories, and that means that they're easily searchable, they're manageable, engineers can modify them. And the CI basically just provides the glue that hooks all the components together and schedules builds. So we have our bot, and we decided very early on that we would take very small incremental steps towards automation. So we wanted to reduce the disruption to our existing process so that we could continue to roll out and continue to release and have value, give value to our users, even as we were developing that automation. So by taking incremental steps, we could just focus on one part of the automation, ensure that it was working before moving on to the next. So in that kind of classic DevOps style, like only change one thing at a time. So for instance, instead of having a developer publish to the App Store, we'd first write a CI build to do the same thing. And this is kind of our fallback and our testing phase. We'd then generate a Slack command that we'd wrap that in so that developers only needed to know how to run that Slack command. And you don't necessarily need to use a Slack command. You could have, but you want something that's super simple, like a web UI or a self-updating Go binary, because hopefully these manual steps will eventually, these manual interventions will eventually become rare, and you don't want to have a lot of dependencies just to run a troubleshooting command. At the very end, we'd actually schedule that thing, or we'd trigger it depending on where in the build process it was supposed to happen. And then we just repeat this for each step that we wanted to automate. So this is kind of a bird's eye view of our release process. You don't need to digest everything here. I'll go through some of the details later. But at the top level are sort of triggers for why a new build can be released or kicked off, why a new beta can be kicked off. And then beneath them is a flow chart of the triggered builds that actually run in response to those initial events. So for example, when translations are complete, we import them, we build a beta, we incorporate testing instructions, we release the beta, and then we send a notification to Slack. And our goal was basically to replace all of these boxes with automated builds. So I'm going to dive into some of the details of that process next. So at this point, again, we're releasing every 2 weeks. And at the beginning of the cycle, we'd cut a new Git branch off of master. And the code in that branch was the basis for what we wanted to release in 2 weeks' time. We'd send a notification to Slack to let everyone know that we're about to cut the Git branch. And then when this was happening manually, the train conductor would ask around like, hey, anyone want to get any more changes in? Are there any critical bugs that we need to block the release on? Like, can I go ahead and do this? And then if they didn't hear anything back, they'd actually go ahead and run the command. So we quickly moved to running this on a schedule. This was the first step we took on. It's an easy step to automate, and this is a screenshot of the Butler schedule UI. It indicates that the next train for Android and iPhone is going to be cut tomorrow, on March 21st, from the master branch. There's a link to the last build that ran, and the only real process change we made here is that we no longer asked anyone if they had anything blocking for the release. We just went ahead and cut it. So in fact, you can see that we scheduled the build to run in the middle of the night so that no one could have any objections to it actually running. So this is actually an ideal step to automate first because it kind of helps set the tone for continuous delivery. And our Slack messages became consistent and guaranteed. It's easy for humans to make mistakes when they're trying to write down numbers or copy dates or do calculations. So making everything automated with a bot makes this a lot simpler and cleaner and more stable. So we already had this process where we'd build from the master branch nightly. and this was sort of like a bleeding edge version of the app that only employees have access to. And it seems this is something that could be done in parallel, obviously, with a regular mobile pipeline automation. But it's very much worth doing because it helps you build confidence that your app builds and runs consistently. And there are other ways to gain this confidence, of course, but incorporating some sort of parallel build and run process into your continuous delivery pipeline is critical. So we schedule our nightly builds in Butler as well. And this continual cycle is also an excellent low-stake opportunity way to ensure that you're consistently building your app on some remote machine or in some Docker container, some sort of place that's not your developers' machines. So because we had this process in place, we decided to tackle the beta version of our app as well. So beta is a slightly different compilation process. So before this process, each developer was actually doing this process on their own machines, which meant that they could have some local library that impacted that development, it impacted that binary, and it might work when someone does it, but it might not work when someone else does it, and we wanted to kind of eliminate that. So by moving all of this to a Docker container, we kind of leveled the playing field and made sure that our builds were repeatable in a totally clean environment. So devs now would use a Slack command to actually like kick off the beta at this point, because we hadn't scheduled it automatically. So in this case, the /butler run is the Slack / command that tells Butler to run a CI build. Android refers to the repository that we're running the build in, so this could be Android or iPhone. And beta is the actual build name that we want to run, so we want to compile the beta. And train 36 is actually the Git branch, so this is the 36th train that we're kicking off, that we want to run our build on. And if you're a train conductor and you ever forget how to do this, there's a helpful Slack command for that as well. So the app would get built in a consistent, clean environment in that Docker container. The resulting artifacts are automatically available. You don't need to manually upload them to S3 or Dropbox. And the CI service just provides you with a link. And we began scheduling these, the last two builds down here, along with the nightlies. And so the train conductor was no longer responsible for doing any of this. But they still had to download those artifacts and upload them to the App Store. And we still needed to release, so this was still happening manually. And so we spent a little bit of time at this point kind of iterating on our scheduling because we didn't want to overwhelm our beta testers and conductors with multiple releases a day. So we didn't want to just build the beta after every single commit. And it's kind of tedious to download the app, so you don't want to be releasing multiple times a day. And so we experimented with a few different approaches, and we landed on doing a single beta a day, provided that there had actually been code changes or translation changes in the app. So let's move on to translations, because these have been a bit of an epic adventure. So initially, after each train branch was cut, the conductor would download all of the source strings, send them off to the translators. They'd actually write out an email and say, hey, translators, can you translate all of these source strings? Then they'd send that off as well. They'd wait. The translators would get back and they'd say, yes, everything's fully translated. They'd download all those new source strings, all those new translated strings. They'd incorporate them into the Git repository and like actually make a commit. And sometimes they had to do this again because we had a bug fix that we needed to get in, so they'd have to go through that same email process again. So the first step here was to begin importing translations automatically as they were processed. And that's sort of what the first build in this screenshot does. And our guiding principle here was that we should only notify the train conductor when something actually went wrong or something was actually missing. So otherwise, we were just going to proceed and assume that everything was OK. So the second build is actually a validation build, and it only starts running near the end of the train. And it ensures that our translations are present and accounted for. And when they aren't, when something actually goes wrong, we send a Slack notification to tell you that something's actually wrong and that you need to take some action, rather than just sending you a notification just because everything's successful. So the second step was actually to just talk to our translation provider and have them start checking every day for new translations instead of based on an email. We did this for the website daily anyways, so this wasn't that burdensome of a request, but it just took a little bit of coordination. This is actually one of the only cases where we could automate something by just talking to people without having to write any code. It was fun, or easy to do. Easy story to accomplish. So we finally added builds that actually pushed our source strings nightly, and once we hooked all of these three components together, we were able to completely automate the translation pipeline. No need for the train conductor to take any manual steps here any longer. And because those translations were being imported automatically, the beta would notice that something had changed in the app, and it would actually build a new beta nightly as well if there were any code or translation changes. We did something similar for our release notes as well. The only difference is that we added a UI wrapper so that product managers could put release notes directly into our app. They didn't have to contact developers to get those notes put into the app strings and have those automatically pushed as well. So it's almost an identical process behind the scenes. It's just there's a nice UI wrapper. And again, Butler kind of like lets us know when translations are ready for the release notes as well. So the final step we're left with, or one of the final steps for automation, is actually publishing that beta to the app stores. So you might think this is kind of like an easy thing to do, right? Apple and Google are multinational tech companies. They would have nice REST APIs. You just like make a single curl call with your upload your stuff, everything goes wrong. That's not how it works. Publishing a new version is actually surprisingly challenging to do in a consistent way. Each app store is different. They don't have very clean APIs. The Android app store allows you to do like percentage-based rollouts in different tracks. The iOS app store requires you to submit first and then like get approval before you can push it out. So there's like slightly different processes in each of them. No very simple APIs. Fortunately, a massive savior here was this Fastlane Ruby gem. And it makes the interactions with the App Store much, much simpler. It kind of provides an API for the App Stores. I think for the iOS one, it actually scripts like click actions in the App Store to get your app submitted. Anyways, we contributed some improvements to this gem as well. And then we wrapped each of the Fastlane calls inside of our own CI builds, like kind of a release beta build that would handle all the quirky app behavior and small interactions so that they were consistent for our Android and iOS apps. For instance, we wouldn't allow a previous version of the beta to get uploaded to an app store if we'd already uploaded a newer version of that beta, something like that, because that was stuff that the Fastlane gem didn't provide for us. So I would say that this undoubtedly was the most technically challenging part of the entire process. And I think it's something that's actively getting better, but the industry has the most advances to make sort of in this area. The web is just light years ahead right now. At this point, we merged our compile task and our publish task, and we just continued to schedule those betas nightly so that releases are automatically pushed out whenever code changes happen and translations are imported. Train conductors are no longer responsible for any part of this process. Betas just actually go out to users. Our actual production rollouts, which you can see a little bit of here at the end, those are actually still Slack commands that we run manually, but they're just Slack commands, and they only get run once or twice on release day. It's a part of the process that we're still building full confidence in before we finally schedule that as well. So at this point, we're almost done with the automation, but we have one other sort of tricky part, which is that we have this external QA thing happening. So testers would actually download betas onto their phones once they were released, and they'd actually go out for a run or a ride to test the app. So how do you incorporate this manual QA feedback if everything is supposed to be fully automated? So let's assume that you're committed to some form of manual QA. You need to have an athlete go out there and experience that application, right? Because we want to test in those hard to test situations where GPS connectivity is low, on different cell phones, where cell phone connectivity is low. What happens in all those cases? What happens when you start to integrate with other biometric trackers? So the main problem in these cases is we can get the testers, we can get them to go out there, but the problem is feedback, because the feedback is very manual, and we don't want to just take a tester's word for it because they're just reporting a single issue that they had. They're trying to kind of quantify a single experience, but it's not necessarily a blocker for release going out. For instance, a bug might just be in some new experimental feature that we're trying to get beta tested, but we can actually turn that feature off and our release can still go out. So the way we resolve this is to kind of just fall back on our philosophy of just assume everything is going to be totally fine and the beta is ready to go out. That's not completely true though, obviously. We still have the train conductor review QA feedback and crash reports, and if they actually determine that something warrants a release halt, they can halt the release, or they can try to get a bug fix in time. But if they don't, the release is just going to go out on time. So the key here is that we basically just keep moving forward. We assume everything is okay, but we have the capacity to stop the process if we feel like something is actually going wrong. So this is sort of like the new age train conducting, where the train conductor just looks out the window. She's in some control panel. She has a bunch of like levers in front of her, and if she sees that a computer is not behaving properly, she can pull a lever and like stop that release. So it's no longer a kind of a manual process. So we also had this final weird process to account for. So when you find a bug in the beta, you have to make a fix, and to get that fix to tested, you need to like get it tested and reviewed, and then you also need to make sure it gets out with that beta, but then you also need to make that same fix on your master branch so that your next beta train has that same fix in place. Because we have that multiple branches, one beta one and one master one, you need to get in both places. So this process is kind of error prone, as you might imagine, because you need to you get your change in place, the beta is fine, but you need to remember to get that change back into the master branch. So we actually built a little Slack bot to help with this. It uses interactive Slack messages, and it attempts to resolve the git changes on its own. So it keeps track of all the changes and basically ensures that we're backporting them. So in this case, if I clicked cherry pick, the bot would try to copy my change over to master, it would run tests, and if everything passed, it would actually merge them to master. If everything succeeded, I'd get a DM that said, hey, congratulations, your change actually landed on master as well. And then if something actually went wrong, like if there was a merge commit, if there was a merge conflict or test didn't pass, the bot would actually generate a GitHub issue, assign it to me, and with instructions on exactly which git SHAs I needed to merge back to master. And you might imagine this might sound like a bit of overkill, but we actually discovered that we were adding approximately 20 commits to our beta trains. And some of them were bug fixes, but a lot of them were actually just quick A/B test changes that we needed to get in because that 2-week cycle was too long for us. So I'll tell you a little bit about that next. But needless to say, this bot was very much worth the investment, and it still is worth the investment even with the 1-week cadence that we have. So because we chose an incremental approach, we had multiple opportunities to educate our developers, and so I held a lot of in-person sessions to kind of go over the details of the new automation as it was being rolled out, and to be able to answer any questions or concerns as the automation was rolling out. So everything, even though everything is automated, things can still go wrong. So you want all your developers to be aware of how errors occur and when they occur, and you want to provide them with all the information they need at that time to make a decision if they need to make one. And this is something we're still working on, obviously. There's always something to improve with your automation. Just because your automation is done doesn't mean you can't make it clearer or cleaner. And basically, it's not just a matter of moving quickly. It's also a matter of kind of moving quickly and gracefully and making that experience a good one for your users, your developers. So we were feeling pretty good at this point. The entire process was streamlined. We were spending about 2 to 3 hours managing a process that used to take us 20. But we still wanted to get down to this kind of 1-week cadence. And again, some of the reasons for this were really that A/B test cycle. With a 2-week cadence, if you get your change in on master right after a train has been cut, you actually have to wait 4 weeks before your release goes out in front of your users. That's still a really long time. Cutting that time down to 2 weeks felt a lot more reasonable. So continuous delivery kind of opens up this whole sliding scale of how you choose to deal with failure. So on one end, you have like a very short release cycle, and you're very willing to accept failure, at least minor bug fixes, or maybe you can like skip a release. And on the other side of that scale, there's like really long releases. As your releases start to reach 2 weeks, 3 weeks, 4 weeks, you're very likely to reject failure. You need to get those bug fixes in. You're going to kind of do whatever it takes to get that release out because it's a really long time till your next release. One option is not necessarily better than the other. It's just that continuous delivery really allows you to move across this spectrum. Because our releases were getting shorter, we actually had to move ourselves kind of further to the shorter side of that cycle and begin really accepting failure as a possibility and as a normal thing that happens. So we'll be doing 52 releases this year. So if we miss 1 or 2, it's not the end of the world. Accepting failure actually feels like kind of a better life choice in general. So I feel pretty good about this decision, but there's definitely an adjustment period here. Moving to 1-week cadence also had some implications for our translation pipeline. And these were probably the most interesting technical challenges because we could no longer guarantee that our translations would be back in time because we only had a week between cut and release. So the way we resolved this is to make all our translations immutable. And that meant that once your source string was merged to master, we actually sent it off to translators immediately, so you couldn't change it. So if you wanted to change it, you'd have to add a new source string, you'd have to wait for that to be translated, and then you'd replace that in the code base. And this meant that translation was happening in parallel with development, so we were no longer as tightly bound to that translation turnaround time. In retrospect, these changes would have been beneficial in the 2-week cadence as well. It's just that we didn't really realize that we needed them until we started shortening that cycle. And we had additional tools to deal with missing translations. For example, we could fall back to English, we could use some default string, we could actually skip a release entirely. And a lot of these techniques don't just apply to translations. We can turn particular features off in our code base, and if they aren't ready for release, for instance. So we can kind of choose along the sliding scale of code versus release as our continuous delivery pipeline gets shorter or longer. But this concept is definitely critical to continuous delivery. The more you can separate code from release, the cleaner and the easier time you'll have moving along that sliding scale. So I'm happy to report that 1 week cadence has been a success for us. We've actually released a little over 10 trains this week. This year, not this week, that would be a lot, with 1 week cadence. And we've validated that the pipeline actually works for us, and that we'll be able to scale based on our product and our engineering growth. We're still only spending on the order of 2 to 3 hours per week managing the process, even though we're releasing twice as often. And I anticipate that the number will actually go down as we continue to improve the builds and we continue to improve our troubleshooting guide, and we get a little more accustomed to this new process. So hopefully this has been informative for you. It's been an awesome process to go through this at Strava. I feel confident that if we can do it, you probably can too. In mobile continuous delivery, there's definitely a lot more tooling that needs to be built compared with web apps. The culture and the ecosystem is still a step behind, but I think it's worth the investment. You'll end up saving a lot of time and releasing more often if you can stick with it. The last thing I'll say is don't underestimate the education and communication component. Cultural changes are difficult, so try to be understanding of the fact that your developers have worked a particular way for possibly a long time, and you're asking them to change their process and undergo some confusion. I can say this though, it's definitely well worth it. So thank you. My name is Pan Thomakos, and you can work at Strava, and you can find me online. Thanks.